In the following video, we're going to look at how to write the equations of parallel and perpendicular lines. We focused in previous lessons on the relationships of slope of parallel and perpendicular lines. And so let's just refresh our memory on that. Parallel lines have the same slope. If the slope of one line is going to equal the slope of the second line. The perpendicular line property is that they are opposite reciprocals. And in the previous lesson, we learned that an easy way to remember this is opposite means opposite signs, different signs. If one's positive, one's negative. And reciprocal means flip the fraction or flip the number that's given to you. So that's opposite reciprocal. So we take these definitions we already know, and we're going to apply them to our writing equations from either starting in point slope form or starting in solve for B approach. So let's try number 9. Write the equation of a line that passes through 2, 3. So here's my point and is parallel to negative 1/2 x plus y equals negative 2. And so parallel tells me I'm looking for the same slope as what it's parallel to, which is negative 1/2 x plus y equals negative 2. Well, in this form, I can't see my slope. So I have to solve this equation into slope-intercept form. So I'm going to add 1/2 x to both sides. Cancels out the negative 1/2 x here. And you get y equals 1/2 x, and it's a minus 2. So that means I have the same slope as what's in this equation for a parallel line. And so in this equation, my slope is 1/2. So my parallel slope that I'm looking for is 1/2. And so now I have a point, I have a slope. And so what I'm going to do in this example is I'm going to use point slope form for my approach to write the equation in slope intercept form. I have a value of 3 for my y1, so y minus 3. My slope for the parallel line is 1/2, and x minus x1, which is 2. So the first thing I do is distribute the 1/2, so I get 1/2 x. 1 times negative 2 is negative 2, divided by 2 is negative 1. And then I add the 3 to the other side to get 1/2 x plus 2. So the equation of a line that passes through 2, 3 and is parallel to negative 1/2 x plus y equals negative 2 is y equals 1/2 x plus 2. It goes through this point 2, 3, and it has the same slope. So that's parallel. So now let's try perpendicular. It's generally the same concept as I worked with before. It passes through 4, 0, and is perpendicular to y minus 1/2 x equals negative 2. Remember, perpendicular means that when you find the slope, it's going to be the opposite reciprocal. In this form, though, I cannot identify my slope. I'm going to have to solve it into slope-intercept form. So I'm going to add my 1/2 x. That is going to cancel out the negative 1/2. So I get y equals 1/2 x minus 2. And so I want the perpendicular slope. And so perpendicular slope, I want the opposite sign of what I see. So this is a positive 1/2. So I'm going to have a negative. And then I flip. So 1 over 2 becomes 2 over 1. So the perpendicular slope is negative 2 over 1, which negative 2 divided by 1 is negative 2. And so now I have my slope and I have my point. For this example, I'm going to use the solve for B approach. Y equals mx plus b. And I'm going to plug in my y, which is 0. I'm going to plug in my slope, which is negative 2. And I'm going to plug in my x, which is 4. And I have plus b. So I'm going to solve for b. 0 equals negative 8 plus b. And so b equals 8. So the equation of line is y equals the negative 2x and then plus 8. That's the equation of line that is perpendicular 2y equals 1/2 x minus 2. I see my perpendicular slope. It goes to the coordinate 4, 0, and I used the solve for b approach to find my y-intercept. So that is perpendicular lines. The approach is generally the same for all of them. You need to identify the slope of the line it's either parallel or perpendicular to, apply the relationship of parallel perpendicular slope, and then use either the solve for b approach or the point slope form approach. And so in the last example, I'm going to use the slope intercept form approach for this. I want to write the equation of a line that passes through 6, -5 and is perpendicular to 3x minus 1/5 y equals 3. So perpendicular again means when I find my slope, I want the opposite reciprocal. So I need to find the slope here. So I am going to subtract my 3x. So I get -1/5 y equals -3x plus 3. And then what I'm going to do is I'm going to multiply both sides by the reciprocal of the coefficient of y. So -1/5 becomes -5 over 1. And so I'm really multiplying both sides by -5. The -5 and the 5 and the 1 and the -1, the negative cancel, the 5's cancel, the 1's cancel. And so I'm left with just my y. -5 and -3x gives me 15x, and -5 and 3 gives me -15. And so I want the perpendicular slope of 15x. So it's a positive 15, so opposite means I want the opposite sign, so this can be a negative. And then I flip it. 15 is really 15 over 1. So flip that, it's 1 over 15. So my perpendicular slope is -1/15. And now that I have a point, I found the slope, I'm going to use, for this example, my point slope form approach. Y minus y1 equals m times x minus x1. So y, it's going to be minus a -5, which really means plus 5, equals your slope, which is -1/15, x minus x1, which is 6. So distribute y plus 5 equals -1/15 x. And when I distribute to the -6, you do -1 times the -6, and then we divide by 15. Negative is a positive. So 6 divided by 15, which can be simplified. 3 goes into 6 twice. 3 goes into 15 5 times. So I get 2/5. And now I subtract my 5 from both sides. And when you're subtracting, it's nice to have a common denominator with your fractions. So when I'm subtracting 5, I'm really subtracting 25/5. And so y equals -1/15 x, and then 2 minus 25 is -23. So the equation of the line is y equals -1/15 x minus 23/5. So you still are going to be dealing with fractions. So we still have to remember those. But understand the process. You're going to have to solve an equation that's parallel perpendicular into slope intercept form. Then based on whether you're trying to find the parallel line or perpendicular line, you apply the relationships of slopes of parallel perpendicular lines, and then you go to your point slope form or your solve for b approach.